Hello everyone, in this video tutorial we will learn how we can do object detection, instance segmentation, pose estimation, image classification and oriented bounding box object detection using YOLO11 and YOLOv8. YOLO11 and YOLOv8 are both state-of-the-art object detection models and both are released by Ultralytics. So let's go ahead and let's dive into the code. So I've already prepared this complete Google Colab notebook and I will be explaining you this complete code step by step. So let's get started with this. So first of all, you can see over here I have in Google Colab notebook, and YOLO11 and YOLOv8 models are available under the Ultralytics package. So in the step number 1, we need to install the Ultralytics package so that we can access both the YOLO11 and YOLOv8 models. Okay. Meanwhile, this package gets installed, I will show you the Ultralytics GitHub page. So over here, you can see we have the Ultralytics GitHub. Okay. So over here, you can see like YOLO11 outperforms all these models, and YOLO11 outperforms the YOLOv8 model as well, which you can see over here. Okay, so YOLO11 comes in 5 different models like YOLO11 Nano, YOLO11 Small, YOLO11 Medium, YOLO11 Large, and YOLO11 Extra Large. So YOLO11 Nano is the fastest among the other YOLO11 models, but it is least accurate. Okay, while like you can see that it has less number of parameters as compared to other YOLO11 models. While YOLO11 extra large model, which you can see over here, is the most accurate model among the other YOLO11 models, but it is less fast, or it is in less speed as compared to other YOLO11 models, because it uses more number of parameters like 56.9 million parameters. Okay, the YOLO11 extra large uses 56.9 million parameters, while YOLO11 Nano uses only 2.6 million parameters, which you can see over here. So you can use these 5 different models for detection as well. We can also do instance segmentation, image classification, pose estimation, and oriented bounding boxes object detection using YOLO11. Meanwhile, let me just give you an overview of the YOLO8 V8 models as well. So here you can see we have the YOLOv8. YOLOv8 is also a state-of-the-art object detection model, and YOLOv8 outperforms YOLO7, YOLOv7, YOLOv6, and YOLOv5. Okay, so YOLOv8 also comes in 5 different model sizes. Yeah, like YOLOv8 Nano, YOLOv8 Small, YOLOv8 Medium, YOLOv8 Large, and YOLOv8 Extra Large. And you can use YOLOv8 model for detection, instant segmentation, pose estimation, oriented bounding box object detection, and image classification as well. So you can use YOLOv8 model for all these tasks, and you can see below the performance matrices as well. So you can check out all these details. Okay. So the YOLOv8 model was released on January 10, 2023, which you can see these details over here. So let's move towards this Google Colab notebook. So you can see that Ultralytics package has been installed, and you can find it over here. So now we only require the Ultralytics package, because like OpenCV, Python, and the packages get installed when we install the Ultralytics package. So now we have installed the required package, and now we will import all the required libraries. So from Ultralytics, I will import YOLO. Okay, and to display any input or output image in Google Colab notebook, so for this, I will import image from ipython.display. So now we are importing all the required libraries over here. So now you can see that we are able to install the Ultralytics package, and you can see these details over here. Now we will download a sample image and a video from my Google Drive into this Google Colab notebook over here. So I'm downloading this sample image and a sample video for the testing purpose only. So now you can see we have downloaded a sample image and a video from a Google Drive into this Google Colab notebook. Now we'll see how we can do object detection on images and videos. Okay, so we'll see how we can do object detection on images and videos using YOLO11 and YOLOv8. So first of all, I will be doing object detection using YOLO11 nano model, and I'm using this bus.jpg image. Okay, and now you can see that this is a command line interface, like this is a CLI command we had toss is equal to detect, as we want to do object detection. If we want to do instance segmentation, then you will just write toss is equal to segment. And if you want to do pose estimation, then you will write toss is equal to pose. Like, and if you want to do image classification, then you will write toss is equal to classify. And we are using the pre-trained model like YOLO11 nano model to do object detection on this input image. So we are not doing the training or validation, we are only predicting. So the mod is equal to predict. Okay, and you can use any of the YOLO11 model. Like I told you, there are 5 different YOLO11 models and YOLOv8 models available, like YOLO11 nano, small, medium, large, and extra light. You can use any of that model as well. So in this tutorial I will be using YOLO11 nano. So let's run this. So now you can see it's downloading the image and it is able to do object detection on this input image. It has detected 4 persons and 1 bus. Let's see the results, how the results look like. So now you can see over here, we are able to detect the bus and the 4 persons that are in this image. So now similarly, you can do this with the YOLOv8 nano model as well. So you will just write YOLOv8 nano. And let's run this now. So now it will download the YOLO8 model weights, and now you can see it has detected the 4 person, 1 bus, and 1 stop sign. Okay. So now you can see over here like the 4 persons. Oh no, this is not my output image. So my output image is saved in predict 2. So I will just need to update this path over here. Okay, so now you can see that with YOLOv8, we are getting a bit better results. Like with YOLO11, we were not able to detect this stop sign, but with YOLOv8, we are able to detect this stop sign as well. So that looks quite promising. Now we will go ahead and we will do object detection using YOLOv8 and YOLO11 on another image. So this is the image that I downloaded from Google Drive into this Google Colab notebook. Let's see how the results look like. So now we will do object detection using YOLO11 on this input image. Okay, so now you can see that we are able to detect 12 persons, 1 bus, and 2 traffic lights, 3 backpacks, and 1 handbag on this input image. And results are saved in predict 3. Okay, so if you just go over here and you will go to detect, and you can see over here we have all these results being saved. So now you can see that we are able to detect this bus, 2 traffic lights. We are able to detect all the persons, backpack, handbag as well. Okay. So these are the results that we got using YOLO11 nano model. Now let's shift towards the YOLOv8 nano model. Okay, so our output image is being saved in detect, predict 4, and here is our output image. So let's run this now. So now you can see the results from YOLO11 and YOLOv8 both looks promising. Okay, so we are able to detect this handbag. Okay, in the previous results, I think only 1 handbag is detected, but currently you can see we are able to detect this handbag as well. So YOLO8 gives us the better results in this case than YOLO11. Okay, so now we will go ahead and see how we can do object detection using YOLO11 nano on this input video. Okay. So the complete video will be divided into multiple frames, and it will be doing object detection on each of the frame one by one. Like you can see, the complete video is being divided into 458 frames, and we are doing object detection on each of the frame one by one. Okay. So I have already saved, run this, and here is my output video in which we are doing object detection using YOLO11 nano model on this video. So here is our output video. So let me just play this over here. So now you can see that we are able to detect the person, bicycles, traffic lights, all this stop sign as well. Okay. So the results look good. Like you can see, you are able to detect this handbag, person, bicycle, and all the traffic lights. Okay. Similarly, you can also do object detection on this input video. You just need to change the model from YOLO11 Nano to YOLOv8 nano, as we have done previously for images as well. So now we will go ahead and see how we can, now you can see that this output video is being saved into predict 5. Okay, so if you just see over here, we have this output video. So you can just copy the path from here. Okay, and you can just add this path over here and you can just simply run this. So this will show you the output video in your Google Colab notebook. So now we have seen that how we can do object detection on images and on videos using YOLO11 and YOLOv8. Now we will see how we can do instance segmentation on images and on videos using YOLO11 and YOLOv8 models. So let's get started with this. So first we'll see how we can do this on images, and then we will go ahead and see how we can do this on videos. So now the task is equal to segment. Previously the task is equal to detect as we were doing object detection. Then mod is equal to predict as we are doing prediction on the images and on videos. And currently we are using the segment model YOLO11 nano dash segment dot pt, like we are using the pre-trained segmentation model. And here we are just passing the input image path. So let's see how does it works. So our results are being saved over here, runs segment predict, like you can see over here. Okay, like you can see this, our output image. So now I will just display this image over here by just running this. So now you can see that we are able to detect the stop sign as well, and just make it look a bit clean. So you can see we are able to detect the stop sign, we are able to detect the person, and we are using the segmentation model. So you can see we are able to draw a mask around each object as well. So now you can see a mask is being drawn around the person, around the first as well, and that looks good. Now I will be using the YOLOv8 segmentation model. So for this, I will just change to YOLOv8 and dash. So now let's see how the results look like. So now you can see that this is a false collection, like this is not a skateboard over here. So with YOLOv8 segmentation model, nano segmentation model, the results look not very much promising, but with YOLO11 nano segmentation model, the results were more promising. Like you can see that the mask is missing over here, the mask is missing over here as well. But with YOLO11 segmentation, I can just show this previous results as well. Now you can see that with YOLO11 nano segmentation model, the results were very promising. Okay. So with YOLO11 nano segmentation model, the results were more promising. Like you can see, there is no false direction of skateboard over here. With YOLOv8 nano segmentation model, there was a false direction of a skateboard. So now we will go ahead and we will see how we can do instance segmentation on this image as well, that we downloaded from Google Drive into this Google Colab notebook. Now results are being saved into this predict tree. So now you can see that we are able to detect dispersed traffic light. Now you can see the detection of traffic light is missing over here. We are able to detect the backpack, and you can see that we are able to detect, we are able to draw a mask around each of the detected object as well. So we are able to draw a mask around each object, and you can see over here, and you can see we are able to draw a very perfect mask around the handbag as well. So now I will now switch to YOLO V8 segmentation model and see how our results look like. So I will be using YOLOv8 nano segmentation model and see how our results look like. So now our result in output image is being saved into the predict 4. So let's navigate towards this. So now you can see that with YOLOv8 nano segmentation model, we are able to detect this traffic light as well. And you can see we are able to draw a mask around each of the object as well. And we have detected that object as well. So now we had done with the images. Now we'll go ahead and see how we can do instance segmentation on videos as well. So now let's run this. So I will be using YOLO11 nano segmentation model. You can use YOLOv8 nano segmentation model as well. So it depends on your choice. So here is our output video. I have already done this, so I will just show you the output video and then we will go ahead. Okay, so let's play this output video over here. Now you can see that we are able to detect the bicycle, person, traffic lights, and you can see that we are able to draw a mask around each of the object as well. Like you can see that we are able to detect the bicycle, traffic light, we are able to detect the person as well. And you can see that we have drawn a mask around each of the object as well. And the results look quite promising as well. So I can just play this output video again as well. Okay, so now you can see we are able to drag the person and draw a mask around this, and we are able to drag the bicycle and we are able to draw a mask around it as well. Okay, so now we will see how we can do pose estimation on the image. So currently I'm using YOLO11 nano pose estimation model. You can also use YOLOv8 nano pose estimation model as well. So let's see. So now you can see over here, it has run and here is our output image, and you can see that we are able to draw, like you can see, we are able to do the pose estimation, and you can see we are able to draw around the key points around the person as well. Like you can see we have drawn all the key points around the person, and you can see that the pose estimation model has been trained on the person data. It has not been trained on the bus or the traffic lights. So if you want to do so for some other object as well, you can just fine tune the pose estimation model on that data. But currently the pose estimation model only support or perform pose estimation on the images, okay, on the persons. Okay, so the pose estimation only perform pose estimation on the persons. Okay, it doesn't perform pose estimation on other objects like glass or some toy or some bus, car, or any vehicles or any other object. Okay, so we only do pose estimation on the persons. But if you want to, the pre-trained model only perform pose estimation on the person. But if you want to do pose estimation on traffic lights or on bus, you need to fine tune the pose estimation model on those key points data. Okay, so now we will go ahead and see how we can do pose estimation with YOLOv8 nano pose estimation model. So you can just write over here YOLOv8 nano, and let's see what the results look like. So now our here is our output image. So you can see that we are able to do pose estimation on the persons here in the image as well. Okay, so now you can also do pose estimation on video as well. So I've already done this. So here is our output video. So now you can see that we are able to detect the person and we are able to draw the key points around each person as well. Okay. So now I will just show you how you can do image classification using YOLO11 model as well as the YOLOv8 model as well. So first of all, let's see using the YOLO11 classification model. Okay, so here is our output image. So now you can see that it has correctly classified that it's a sports car, and the 66% probability is that it's a sports car. Okay, so now you can also use YOLOv8 classification model as well. So here we are using the YOLOv8 classification model. And let's see the result. So the what is output image is being saved in this related to. So now with YOLOv8 it classification model, it's like 74% like uh, there's a 74% probability that it's a sports car. Like YOLOv8 classification model performs better. Okay, so now we will see how we can do oriented bounding box object detection using YOLO11 and YOLOv8. So oriented object detection like takes one step further. Object detection takes object detection one step further by introducing an extra angle to locate objects more accurately in an image or in a video. Okay, so first we'll use the YOLO11 nano oriented bounding boxes model. So let's see our output image, and now you can see we are able to detect and locate every single ship that are in this video and in this image, and we are also able to locate the harbor as well. Okay, so let's use the YOLOv8 nano oriented bounding boxes. So here we have the predict bloom. So now you can see that we are able to detect and locate the ship that are in this image very accurately, and the harbor as well. So that's all from this video. In this video tutorial, we have seen that how we can do object detection, instant segmentation, pose estimation, image classification, and oriented bounding boxes. Object detection using YOLO11 and YOLOv8 on images and on video. So that's all from this tutorial. Thank you for watching.